Imagine this. It's the year 3000. Earth is a distant memory, a blue gem lost in the vastness of space. Humanity has spread across the solar system, building colossal space cities, orbiting Jupiter, colonies beneath the ice of Europa, and mining, stations deep within the asteroid belt. But despite all this progress, one challenge remains: energy. The further we expand, the more power we need. A single planet's resources are no longer enough. Fusion reactors provide some relief. Solar panels stretch across Martian deserts, and nuclear stations hum in the depths of space. But it's not enough. Our civilization is still shackled by energy limitations. Then one day a solution presents itself, a structure so massive, so ambitious, that it could rewrite the fate of our species, the Dyson Sphere. But wait, before we dive into whether we could ever build one, let's break this down from the very beginning. What exactly is a Dyson Sphere, and why is it considered the ultimate megastructure? The concept dates back to 1960, when physicist Freeman Dyson proposed a thought experiment. If an advanced civilization wanted to maximize its energy use, it wouldn't rely on small-scale sources like fossil fuels or wind turbines. It would harness the full power of its star. Dyson speculated that intelligent beings would eventually surround their star with energy-absorbing structures, capturing nearly all of its radiation and using it to power their civilization. To understand just how much power we're talking about, let's put things in perspective. Right now, all of humanity's energy consumption, everything from our factories and homes to our internet and spacecraft, amounts to about 20 terawatts. That's a staggering amount, but it's nothing compared to the energy output of the sun. Every single second, our sun emits nearly 400 septillion watts of power. That's a 4 followed by 26 zeros. It's an amount so vast that if we could harness even a fraction of it, we'd never run out of energy again. Ever. At this point, you might be picturing a giant, solid metal shell surrounding the sun, like something out of a sci-fi movie. But a rigid sphere like that wouldn't work. The gravitational forces involved would be catastrophic. Any solid shell would be torn apart by tidal forces, solar winds, and instability. Instead, the most realistic designs involve what's called a Dyson swarm, millions, even billions, of satellites orbiting in synchronized formation, collecting solar energy and transmitting it wirelessly to receivers on Earth, the Moon, or even distant space stations. Now, why would we even need such a colossal structure? Right now, energy is the foundation of everything we do. But as our technological demands grow, we're going to hit a limit. Our fossil fuel reserves are finite. Even if we master nuclear fusion, it won't be enough to sustain interstellar travel or vast space colonies. If humanity wants to become a multiplanetary species, we'll need an energy source as vast as space itself. That's where the Dyson Sphere comes in. But let's pause for a moment. Just how difficult would it be to construct something like this? The sheer scale of it is almost incomprehensible. To build even a partial Dyson swarm, we'd need more raw materials than exist on Earth. That means mining asteroids, dismantling entire moons, or even breaking apart planets like Mercury to get enough metal and resources. The logistics alone are mind-boggling. How would we transport these materials? How would we construct and maintain a network of billions of solar-collecting satellites in space? And what about the risks? Would the structure itself create unforeseen problems for our solar system? Before we get into the challenges, let's take a step back and look at what this would mean for our place in the cosmos. According to the Kardashev scale, which measures a civilization's technological advancement based on its energy consumption, humanity is currently at around 0.7. A fully functioning Dyson Sphere would push us beyond Type 1, past planetary control of energy, and into Type 2, a civilization capable of harnessing the full power of its star. To put it bluntly, achieving this would mean we are no longer a primitive Earth-bound species. We'd be something else entirely, a force of nature, capable of reshaping entire solar systems. At this point, it's clear. A Dyson Sphere isn't just a futuristic idea, it's the next step in our evolution. If we can pull it off, it would unlock a future where energy is limitless, space travel is unrestricted, and entire new worlds become possible. But before we dream too far ahead, we have to ask the hard question, can we actually build one? What technological hurdles stand in our way? What would it take to go from where we are today to a civilization that could pull off something this grand? Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. In the next section, we'll break down the massive challenges standing in our way. From material shortages to engineering breakthroughs, we'll explore whether humanity's current trajectory could ever lead us to building a Dyson Sphere, or if it's just a dream too big to chase. So, we've established that a Dyson Sphere could revolutionize civilization, transforming us from a planet-bound species into an interstellar force. But now comes the real challenge. How do we actually build one? The obstacles are staggering, the requirements are astronomical, and the technology, well, let's just say we're nowhere near ready. But does that mean it's impossible? To understand the scale of this endeavor, imagine constructing something larger than the entire solar system as we know it. The sheer amount of material needed is beyond anything humanity has ever extracted, refined, or utilized in history. Right now, all of Earth's infrastructure, from our tallest skyscrapers to our deepest mines, amounts to a fraction of what we'd need to build even a partial Dyson swarm. So, where would we get the raw materials? Mining the solar system. A. New age of industry Earth alone doesn't have enough metal to build a Dyson swarm. If we're serious about harnessing the power of our star, we'll have to look beyond our planet. That means mining the moon, asteroids, and potentially even entire planets. Let's start with the asteroid belt. Between Mars and Jupiter lies a vast region filled with millions of asteroids, some rich in iron, nickel, and cobalt, the very metals we'd need for building Dyson satellites. One particular asteroid, 16 Psyche, is believed to contain enough metal to supply humanity with resources for millions of years. Mining it could be the first step toward gathering the materials necessary to construct large-scale solar collectors in space. But mining asteroids is no small task. We'd need autonomous mining drones, massive processing stations, and robotic factories that can operate in the vacuum of space. And even if we manage to extract these materials, how do we transport them to where they're needed? Rocket launches are too inefficient. We'd need something like a space elevator or a mass driver, a giant electromagnetic catapult that could shoot mined materials directly into orbit without needing tons of fuel. Even more extreme. Some theories propose dismantling Mercury. Yes, an entire planet. Why? Because it's close to the sun, rich in metals, and small enough that breaking it apart could yield enough material to construct a Dyson swarm without depleting the rest of the solar system. But of course, destroying a planet comes with consequences. We can't even begin to predict, altering planetary orbits, shifting solar radiation patterns, and who knows what else. Would we really take that risk? Engineering on an impossible scale. Let's say we figure out where to get the materials. Now comes the hard part, assembling the Dyson swarm. How do you build and maintain billions of solar collectors in space? The only viable answer? Self-replicating. Machines. Instead of humans painstakingly building each part, we'd need robotic factories that can create copies of themselves. Imagine sending just one autonomous assembly plant into space, designed to extract metals from asteroids, manufacture new collectors, and then build more factories, which in turn build more. Within a few decades, these self-replicating machines could multiply exponentially, constructing an entire Dyson swarm piece by piece, without human intervention. But even this approach presents enormous challenges. Space is hostile. Solar flares, radiation storms, and collisions with micrometeoroids could damage or destroy these satellites before they even start collecting energy. So how do we make them durable? Could we design nanomaterials or self-healing structures that can repair themselves when damaged? These are the questions engineers of the future will have to answer. Energy transmission. How do we get power from the sun to us? Let's say by some miracle we succeed in building a Dyson swarm. Millions of solar collectors are now orbiting the sun, absorbing its energy. But there's still one massive problem. How do we send that energy back to Earth? A solid wire? Impossible. No material could stretch that far. Transporting batteries? Impractical. So, what's the solution? Wireless energy transmission. The most promising idea is microwave or laser transmission. The satellites would convert sunlight into electromagnetic waves and beam that energy to receiving stations on Earth or space colonies. These stations, equipped with giant antennas, would then convert that energy into electricity. But this raises another issue. What happens if something interferes with the transmission? Could a misaligned satellite accidentally fire a concentrated beam of energy onto a city, causing devastation? And what about efficiency? Even the best wireless energy transfer methods today suffer from power loss over long distances. Could we develop a new technology that minimizes energy waste? The human factor. Are we ready for this? Even if the technology existed, is humanity truly ready for something this ambitious? The construction of a Dyson Sphere wouldn't just be a technological challenge, it would be a test of our ability to cooperate on a global scale. Right now, even small-scale international projects face political disagreements, funding issues, and competing interests. The idea of uniting nations, or even competing spacefaring civilizations, to build a Dyson Sphere seems almost as improbable as the engineering itself. Would nations put aside their differences to create a shared energy future? Or would Dyson Sphere construction spark a new kind of space race, one where different powers compete to control the ultimate energy source? And then there's an even darker question. If one group controlled all the energy of the sun, would that make them the rulers of the solar system? Would a Dyson Sphere lead to an age of unimaginable prosperity or an era of energy-based warfare, where control of solar power determines who thrives and who perishes? Are we taking the first steps already? Despite these challenges, we're already laying the groundwork for Dyson Sphere construction in ways most people don't realize. Right now, NASA and private companies like SpaceX, Blue Origin, and China's National Space Administration are actively working on space mining, robotic manufacturing, and new forms of energy transmission. The first self-replicating robots could be tested in the next few decades. Space-based solar power stations are already in development. So, while a full Dyson Sphere may be centuries or even millennia away, the seeds of its creation are being planted right now. The question is, will we follow through? Will we ever reach a point where humanity is ready to take on this challenge? In the next section, we'll explore an even bigger question. If Dyson Spheres are the ultimate sign of an advanced civilization, why haven't we seen any? If aliens exist, and if this is truly the next stage of technological evolution, why doesn't space seem filled with these megastructures? Could there be an unseen barrier that prevents civilizations from reaching this level? Or could this answer be something far stranger than we ever imagined? Imagine this. It's the year 5000. Humanity has done the impossible. We've built a Dyson swarm. A vast web of solar collectors now encircles the sun, absorbing its energy and beaming it across the solar system. Cities float above the clouds of Venus. Martian colonies stretch across the red deserts, and deep space stations orbit Jupiter, powered by the boundless energy of our star. We are no longer just inhabitants of a single planet. We are architects of a stellar empire. But here's the chilling thought. If a Dyson Sphere is the next step in a civilization's evolution, shouldn't we have seen one by now? This brings us to one of the greatest mysteries in astrophysics, the Fermi Paradox, the unsettling contradiction between the high probability of intelligent life in the universe and the deafening silence of space. The universe is billions of years old. If advanced civilizations emerge naturally over time, some of them should have already built Dyson Spheres, or at the very least, Dyson swarms. Their existence should be obvious. We should see their stars mysteriously dimmed by orbiting megastructures or detect their immense energy signatures, and yet, we don't. So what's stopping advanced civilizations from building Dyson Spheres? Could something be wiping them out before they reach that stage? Or, perhaps even more unsettling, are Dyson Spheres everywhere, but we simply don't recognize them? The great filter. Is there a barrier we haven't crossed yet? One possible answer comes from an eerie hypothesis called the Great Filter. It suggests that there's some kind of near insurmountable obstacle that prevents civilizations from progressing beyond a certain point. Maybe life itself is incredibly rare. Maybe intelligent species tend to self-destruct before they can reach the stars, through war, environmental collapse, or uncontrolled artificial intelligence. Or maybe, just maybe, building a Dyson Sphere is the last step a civilization ever takes before something happens that we don't understand. Could it be that civilizations who attempt to harness the full power of their star attract unwanted attention? Imagine a species constructing a Dyson Sphere, advertising its technological might to the entire galaxy. What if there's something out there watching, something that sees Dyson Spheres as threats? Could the silence of the cosmos be the result of civilizations that were removed? Are we looking in the wrong places? Of course, there's also the possibility that Dyson Spheres do exist, but we simply don't know how to recognize them. We typically search for alien life by looking for planets, but an advanced civilization might not need planets at all. They might live in artificial megastructures, orbiting their stars in vast, self-sustaining habitats. If a Dyson Sphere exists around a distant star, it might emit infrared radiation rather than visible light, blending in with the cosmic background. In fact, some researchers have already searched for these signs. Astronomers have examined thousands of stars, looking for unusual dimming patterns that could indicate a Dyson swarm in progress. One of the most famous examples is Tabby's star, a star that exhibits strange, irregular dips in brightness. Some scientists speculated that this could be evidence of an incomplete Dyson swarm, but further studies suggested it was likely caused by a cloud of dust. So if Dyson Spheres are out there, they're either incredibly rare, incredibly well hidden, or something is preventing them from being completed. The Dark Forest Hypothesis A. Reason to stay silent. There's one more theory, and it's perhaps the most unsettling of all. In Liu Cixin's sci-fi novel, The Dark Forest, he proposes a terrifying idea. The reason space is silent is because advanced civilizations know that making themselves visible is a death sentence. Imagine the universe as a vast, dark forest. Every civilization is like a hidden hunter, lurking in the shadows. The moment one reveals its location, by broadcasting messages, building megastructures, or sending out probes, it risks being found. And in a universe where resources are finite, any sufficiently advanced species might see another as a potential future threat, one that's best eliminated before it can grow too powerful. If this theory is true, then civilizations may deliberately avoid building Dyson Spheres, fearing that they'd shine like a cosmic beacon, advertising their presence to the unknown. Could we be the first, or maybe there's a far simpler explanation? Maybe we are the first. The universe is young, just 13.8 billion years old. While that might sound ancient, it's possible that intelligent life simply takes a long time to develop. Earth itself has existed for over 4.5 billion years, yet humans only emerged in the last 300,000 years. Advanced civilization, only in the last few thousand. What if intelligent life is just now emerging across the cosmos? What if Dyson Spheres aren't missing because of some great cosmic horror, but simply because no one has built one yet? And that leads us to a profound possibility. What if we are the first species to even attempt it? If that's the case, then the responsibility falls on us to explore, to expand, to push beyond our limits and take our first steps toward harnessing the power of our star. But before we do, we have to ask one final question. Should we? In the next section, we'll confront the greatest dilemma of all. If humanity ever does reach the point where we can construct a Dyson Sphere, should we actually go through with it? What if the risks outweigh the rewards? What if there are dangers we haven't foreseen? And what if building a Dyson Sphere sets us on a path we can never return from? The future of our species could depend on our answer. So here we are. We've explored the grand vision of a Dyson Sphere, how it could transform civilization, the colossal challenges of building one, and the unsettling question of why we haven't seen any in the universe. But now we face a dilemma that may be even greater than all of that. If humanity ever reaches the point where we can build a Dyson sphere, should we actually do it? Because, as much as this idea promises unlimited energy and a future beyond Earth, it also comes with risks we may not fully understand. Some dangers are practical, some are ethical, and some venture into the unknown. The ethical and existential dilemmas of a Dyson sphere. Let's start with a simple question. What happens to Earth? A fully completed Dyson sphere, if built as a solid shell, would completely enclose the Sun. That means no sunlight would ever reach Earth again. Our planet would be plunged into eternal darkness, a frozen wasteland with no natural source of energy. Even if we opt for a Dyson swarm, a vast network of independent satellites rather than a single megastructure, there's still a risk of disrupting the delicate balance of sunlight that keeps our climate stable. Could we control how much energy we harvest without accidentally triggering an ecological catastrophe? And then there's the question of who controls it. Imagine a future where a single organization, whether a government, a corporation, or even an artificial intelligence, holds absolute control over the energy of an entire star. Energy is the foundation of civilization. Every device, every vehicle, every factory, every city, everything depends on it. Whoever controls that power would have an unimaginable advantage over the rest of humanity. Would a Dyson sphere lead to a golden age of prosperity, or a dystopian future where one entity holds absolute dominance over the solar system? Would nations fight over it? Would there be wars, not for land, not for oil, but for control of the sun itself? And if a war broke out over a Dyson sphere, could it result in the destruction of our entire energy infrastructure? Imagine an act of sabotage that disables or destroys the collectors, plunging all of human civilization into darkness in an instant. The dangers of playing with stellar power, but let's assume for a moment that we solve these political and ethical challenges, that humanity works together and builds a Dyson swarm with the intention of creating a utopian future. Even then, we could be playing with forces beyond our control. Consider this. The sun is not an infinite energy source. Yes, it burns with almost 400 septillion watts of power every second. But if we start harvesting that energy on an industrial scale, could we unknowingly alter the star's behavior? Stars maintain a delicate balance between gravity and radiation pressure. If we begin capturing vast amounts of energy, could we accidentally trigger instabilities in the sun? Could we speed up its life cycle, causing it to burn out faster? Could our interference cause unpredictable solar storms, flares, or even collapse? And if that happens, if we mess with a force we barely understand, could we doom ourselves before we even get the chance to become a true interstellar species? The point of no return. Do we cross it? But maybe, just maybe, this is the test every civilization must face. What if every advanced species eventually reaches a point where they must decide? Do we take the next step and harness the power of our star? Or do we hesitate, fearing what might come next? Because once we build a Dyson sphere, we are no longer bound to Earth. We are no longer even bound to the solar system. A civilization with access to this kind of energy could send colony ships to other stars, transform planets, build habitats the size of worlds. A Dyson sphere isn't just an energy solution. It's a doorway to a new type of existence. But stepping through that doorway means there's no going back. Humanity would no longer be what it once was. The civilization that builds a Dyson sphere is no longer the civilization of small villages, of nations, of planetary borders. It becomes something unrecognizable, something post-human, something more. And that's the final question we must ask ourselves. Not just can we build a Dyson sphere, not just how we'd build it, not just why we don't see them in the universe, but if we do this, will we still be us? The final thought. In the end, a Dyson sphere represents the ultimate gamble, unimaginable power and boundless potential. But also the risk of losing everything we know. It's a paradox. The very thing that could save us could also destroy us. Maybe that's why we don't see them out there. Maybe other civilizations have faced this very same choice and decided not to take the risk. But if we ever do reach that point, if we stand on the edge of this decision, what will we choose? And now we turn to you. Do you think humanity should attempt to build a Dyson Sphere? Would it lead to our greatest golden age or our downfall? Let us know in the comments. And if you enjoyed unraveling the mysteries of the cosmos, give this video a like and share it with fellow space enthusiasts. The universe is full of questions waiting to be explored, and together we'll keep searching for the answers.